2.6 here for college prep today is titled Characteristics of Quadratic Functions. Okay, and the thing we're trying to answer today is right here. How about a volunteer to read this for me today?
That's a question.
Yeah.
What type of symmetry does the graph of f of x equals a in parentheses x minus h squared plus k have, and how can you describe this symmetry?
What's this word mean right here?
It's the same.
Okay, so it's the same. So give me an example where symmetry might exist. If I say something symmetric. So basically, one half mirrors the other half, okay? And today, guys, if I look at this right here, what family of functions are we dealing with again today? What family are we dealing with? Oh, I'm sorry, here. Okay. Any more over there? Okay. Okay, what kind of a shape is the family of functions we're dealing with right now? Is parabola, right? Right? And guys, today what we're going to kind of look at is this. The big idea here is going to be this. If we're talking about lines of symmetry related to parabolas, and if we know a line of symmetry cuts something in half right here, say maybe, I don't know, like this. In a parabola, isn't the left side going to mirror the right side? Okay, here's a question for you. If that's a parabola drawn up there, and that red line is my line of symmetry, what point does my line of symmetry pass through on the parabola? The what? Okay, this is going to be really important today. It is going to go through the vertex. All right? So again, the question, what type of symmetry does the graph of f of x equal a times the quantity x minus h squared plus k have, and how can you describe the symmetry? All right? So today we're going to look at exploring those properties of parabolas. We're going to find what's minimum and maximum of our quadratic functions. Again, a quadratic is just a parabola. Okay, that's the family we're dealing with. We're going to look at some graphs of quadratic functions using x-intercepts, and then we're going to look at also rewriting some equations today to answer that question. So to get started, we need to make sure vocabulary is in order. So kind of talked about the first one, axis of symmetry for me. Who wants to read that? Volunteer to read axis of symmetry for me.
A line that divides a parabola into mirror images and passes through the vertex.
Didn't we just draw that up top, kids? Okay, it's a parabola. Looks like this. And the line of symmetry is simply just going to cut right through the middle. And it's going to pass through that point, which is called the... It's going to pass through the point called the... Yeah. By the way, is that vertex a minimum value or a maximum value in the sketch? Minimum. It's at the bottom, isn't it? Okay. What are you going to have a maximum value for a quadratic? Instead of a U shape, we have an arch, like that thing in St. Louis. Okay. Anybody been in the arch ever before? In St. Louis? I have a t-shirt that says y equals negative x squared plus 630. St. Louis Arch. It's pretty cool. Negative x squared. The negative takes the u and flips it, and then 630 moves it 630 feet in the air. Get it? Does that make you weird? You guys are all looking at me like I'm some sort of weirdo. You know that? You should see what I see right now. All right, standard form right here. Standard form of any quadratic is going to be of the form f of x equals ax squared plus bx plus c. A cannot equal what value, kids? 0. So an example might be, I don't know, maybe f of x equals 3x squared plus 2x minus 12. Guys, if I had to ask you this right here, if that's standard form, that's going to be kind of new for us, that's standard form of quadratic. In that example, what's the a value? Ooh, careful. 3 is, right? What's the b value? 2. And what's your c value? Negative 12. Okay? All right, minimum value, kids. We kind of know what this is. I'll read the definition. We'll kind of simplify it over here. Minimum value for any quadratic function, f of x equals ax squared plus bx plus c. The y-coordinate of the vertex is the minimum value of a function when a is greater than 0. So here's the deal. If a is ever positive in standard form, you end up with a U-shaped graph, which is going to imply a minimum at the vertex. So if the a value is ever what here, kids? Positive. What kind of a shape you can end up with? U-shaped, and that's going to imply some kind of a vertex where that value is a minimum value. So what do you think is going to happen if a is negative? If a is ever negative in these types of situations, you're not going to get a U-shape, but rather get an arch, because if I put a negative out in front, it flips stuff over the x-axis. We've talked about that. That's going to imply some kind of maximum vertex. Okay? And then lastly today, we'll look at what's called intercept form. Okay? We'll look at what's called intercept form. I have a volunteer to read that for me today.
When the graph of the quadratic function has at least one x negative intercept, the function can be written in an intercept form f of x equals a in parentheses x minus p in parentheses x minus q, where a is not equal to.
Clear as mud, right? Should we try to see if we can't figure this out? Okay, first of all, what's an x-intercept, kids? If I had a coordinate plane and a graph has x-intercepts, remind me again what x-intercepts are. So it's where the graph crosses the, not the y-axis, but the x-axis, right? Okay. Sometimes parabolas can be written in a form where, if I have this right here, I'm gonna just sketch this real quickly. Let's say, how many times did that graph cross the x-axis, kids? Twice. Okay. And I'll show you what this means right here. These 2 points right here are x-intercepts, and we can write stuff. If you have 2 points that cross the x-axis like that, you can write this in what's known as intercept form. Okay. And I'm going to write this down. Only works if the graph crosses which axis again? Which 2 points did I highlight? Yep. This is only going to work if the graph crosses the x-axis. And then the form we're going to take on here, kids, is f of x is equal to a times x minus p and x minus q. What I need you to understand is p and q are kind of like the values of the x-axis that they cross at. Okay. So p and q, might want to write this down. P and q are your x-intercepts. Okay, so just do a double check here before we start getting into what we're trying to accomplish. We'll come back and visit it again. All right? But take a look at what we're trying to accomplish here. Do you guys have all the vocabulary first?
No, not yet.
Okay, I'll wait for you. Anybody need more time vocab? Again, question. We're trying to figure out what does symmetry do for a graph, okay? So here we go on this. This is really pretty simple. I think that once you get established, you'll really know what's going on. Now, my graphs didn't show up very well. Take a look at your graphs and yours. Did yours show up pretty well on page 2 there, kids? Can I see someone's notes? Tell me they showed up nicely. Oh, they did. So you're in good shape there. My lines are a little goofy up here today. Can you tell, kids? So I'm going to choose to do this here quickly. I'm going to get me a new coordinate plane. I'm going to use a different coordinate plane for my problems, but we'll be okay. So give me a second here. Let's see. Gallery. Mathematics. Let's see if I can get the good one to work. Please work. Please work. Please work. It didn't. Why does that do that all the time, kids? See how the XY axis is here and then the numbers are way off? Anybody know why that does that? I know why. You want to know why? Hello, Earth to you guys. Are you alive today? Anybody out there alive today?
Good job, you fixed it.
Stay up till 1 watching baseball.
Oh, did you? I went to bed. All right, I'll be kind of flipping back and forth here. We'll make sense of this today, okay? All right, kids, back on your notes here. On the second page right here, example 1. Up here in example 1, it says using what, kids? Symmetry to... Okay, no problem. Here's what we're going to do today. First of all, kids, we have what's known as vertex form right here. It says graph f of x equals 0.5 times x plus 4 squared minus what? 2. It says write and label the vertex in the axis of symmetry. Okay. All right, kids, if this is in vertex form, what becomes the vertex first of all? Isn't this in the form of a times x minus h plus k right here, kids? Okay. What's the h value here, guys? Okay, careful on it. It's kind of the opposite of this up here. So what value would go in here to make that 0? Okay, so I'm going to say right here my vertex is going to be at the point -4, comma. How about the k value? What's the k value up there? -2. Okay. So you're going to graph stuff over here. I'm going to be flipping back and forth to my graphs here. Okay, so why have a vertex? What did we say the vertex was again, kids? I just told you. I can't remember. -4, 2?
Yeah. No, negative.
So I think the vertex is right here. -4, -2. Is that right, kids? So on your graph that point. That's going to be our vertex. All right? So here's how this is going to work. Once you have this established right here, it says draw in a line of what, kids? Okay, I'm going to just draw a line of symmetry here real quickly. I'll do my best. Maybe a line of symmetry is right here at -4. It's going to cut this right in half like so.
How do you, okay. Can it be going sideways or no? Is it always?
It could be, but for our purposes, it's always going to be vertical right now. Okay, because we either are dealing with a U shape or an arch. Okay, we're not going to look at sideways stuff yet. Okay, so my line of symmetry right here is that x equals what value? What x value did this cross at, kids? -4. Okay, so here's what we're going to do. We know our vertex here is at x equals -4. So what we're going to do is just form a table now, kids. Okay, what I like to do is this. I'm going to put -4 kind of in the middle right here because the vertex -4 occur at -4 comma what, kids? -2. And then here's what we're going to choose to do. Okay, we're going to kind of work our way away from the line of symmetry because you already told me if a parabola is symmetric, what's on the right is going to mirror what's on the left side here, right? Okay, so here's how this works. What you end up doing after I go back and look at my graph, I might say, all right, kids, right here, I know that my minimum point is going to be down here. So what we're going to do is this. What x value was this up here? What x value does the line of symmetry pass through? -4. So I'm going to look at values to the left and to the right of this. So I'm going to look at -3 and at -5. And then after I look at -3 and -5, I might come out here and look at -2 and -6. And over here, I'm going to look at -1 and maybe -7. So here's what I want to do. Okay? Once I figure out where your vertex is, I kind of put that right in the middle of my table like so. And here we go. I'm going to look at -3 and at -5. I'm going to go one above the line of symmetry value and then one below the line of symmetry value. So what I need somebody to do then is this. Do I have any volunteers that are going to help me today? Say yes, please.
Yes.
Who's willing to plug -3 in for x and tell me what you get out up here? Anybody? Who would be willing to plug -3 in for x and get a value for me?
I will.
Annika, who's willing to put -5 in there for me? You guys are scaring me this morning. You guys, are you alive? Give me some sort of sign that you're alive right now. Do I need to call the 911?
Yes.
I don't know the number though.
-3 is -1.5.
-1.5?
Yeah. What other one did you need?
-5. Plug -5 in there. -1. Oh my gosh, what did you notice about these two values? They're the same. So one point is -3 comma -1.5. The other is -5 comma -1.5. You start going the same distance from your vertex left and right. Don't you get the same values out? That's what symmetry is. It mirrors itself. So right here, the next point that you would graph would be, okay, you said -3. When you put -3 in, you got -1.5. Is that right? So here, and -5, -1.5. Those 2 points mirror each other right there. Okay? So let's go a couple more values. Right here, I need someone to plug -2 in. Help me, kids. What's -2 plus 4? 2 squared would be 4. So what's half of 4? 2 minus 2 would be 0. So if I plug -2 in and get 0 out, what do you think we're going to get when we plug -6 in then, if this pattern is going to be symmetric? 0. Yep. Okay. Yeah, once you know your vertex right here, this point being your vertex, you can kind of work each way. So I'm going to plot the points -2, 0, and what else, kids? 6, 0. Now again, keep in mind, this is in what form? Well, it's called intercept form. Okay. So, same game. -2, 0 is going to be the graph next. Where'd my graph go? There it is. -2, 0. So left 2 and 0. And left 6 and 0. Okay, let's just do one more point to get a fairly accurate sketch of this. All right? You guys are going to help me with this. Okay. Let's put in -1 and -7. I'll put -7 in here because I'm kind of running out of room. If I put -7 down here, what's -7 plus 4, kids? -3 squared becomes a positive 9, right? Okay, so 9, what's half of 9 now? 4.5 minus 2? 2.5. So we're going to have the point -7 comma 2.5. Gosh, guys, if -7 was 2.5, go to the other side. What would -1 be? So we're going to have -1 comma 2.5. I don't know where to put that. How about we try this? That didn't work the way I wanted it to. Gosh darn it. Okay. What did we say we would get when we had -1 in there? 2.5. Okay, so let's mirror this again. -7, 2.5, -1, 2.5. So on my graph right here, and you have the same thing on your graph, hopefully. negative 1, comma, 1, 2.5. Kids, what graph appears to be a forming here? Parabola. Once you have those points, you're simply just going to go ahead and sketch this as best you can. And this is the best parabola I know how to sketch right here. Oh my gosh, it didn't like that very much, did it? Try this again. Yeah. Okay, first thing you're going to find is which pointing, kids. It's just negative 4, negative 2. That's my vertex. Once you know where the vertex is, run your line of symmetry through there. Determine your x value on the line of symmetry, and then start working outward from that for points. Pretty simple. Okay. Now again, keep in mind this was vertex form. Finding vertex on this was very easy. We looked at this the other day. We said, oh, negative 4, comma, negative 2. That's easy to see it. When this is in vertex form, and maybe I should write this down by example 1, vertex form is the form you're dealing with here. Okay? Vertex form is the form you're dealing with here. Now, questions about that so far? Okay? All of a sudden, instead of working vertex form right here, they come down here and say, what if I wanted to graph a quadratic function in, what's this say here, kids? Standard form. Okay, so standard form is of the form ax squared plus bx plus c. All right? This one here is a little trickier, but I will tell you this right here. This is the most common type of quadratic you're going to see, and this is probably going to be the most common type of problem you're going to see in the future as you move through working with quadratics. Okay? It says graph a quadratic function in standard form. We are to graph f of x equals what, kids? 0.5x squared minus
4x
minus 2. Now I'm going to give you some rules up here, and these are going to be really important rules. Okay? I like to list in these right here in standard form all the time what my a value is. So in this equation right here, what's the a value? What's the a value? Half. What's your b value, kids? B is equal to negative 2. And c is going to equal... Whoops, I've got that wrong, don't I? What's your b value again? Negative 4. What's c? Negative 2. Okay, so we've established that. All right? First thing that we wanted to find up here was kind of use the line of symmetry and vertex right here. Now when you're dealing standard form, here are your steps. Okay? What you want to do all the time is the following. Step 1. Find. Is it okay if I abbreviate it LOS like this? Anybody have a guess what that means? Line of what again, Maddie?
Symmetry.
Line of symmetry. Very good. Anybody know how to find a line of symmetry in standard form? Okay. The way you find a line of symmetry is simply found by saying x equals the opposite of b over 2a. All right, the opposite of your b value over 2 times a. All right, that's going to be very important for us. So let's do this real quickly. In step 1, my line of symmetry, x equal, what is the opposite of b so far, kids? 4. And this will be over 2 times what value? What's the a value? Come on, guys. What's the a value? 0.5. Okay, what is 2 times 0.5 in the bottom? 1. Okay, my line of symmetry is going to be at 4 divided by 1 now, which is what value? 4. So you're going to be at x equals 4 right here. Okay, we found our line of symmetry. Okay, now here's how this works. My line of symmetry is at 4, so I'm going to go to my graph here. And what you want to do is this. On the x-axis, you want to run over, what value do we find for line of symmetry again, kids? What is that value again? 4. Okay, so you're going to count over 1, 2, 3, 4. Let's get that vertical line of symmetry put in there. So here it is. Right there at x equal 4, that's your line of symmetry. Now tell me again, which point does that line of symmetry pass through? On your quadratic or your parabola, which point is that line of symmetry going to pass through? What point does a line of symmetry pass through? It does pass through 4, but what's that point called on the parabola?
Vertex.
Yeah, the vertex, okay? So what I want to tell you here next then is this. Our job here, simply put, is say, well, you've established the line of symmetry. So step 2 right here says, boy, it would sure be nice if I knew where the vertex was. Okay? Well, once you know the line of symmetry, it's quite simple. Because all you're going to do is say, well, I already know the x value because you just told me the line of symmetry passes through the vertex. So to find the vertex right here, simply plug in your line of symmetry. Okay? Plug in your line of symmetry. What was my line of symmetry value there, kiddos? 4. Okay, so back up to my quadratic function in standard form. What are you going to plug in for x? So we're really evaluating f of 4. When I input 4, we get 0.5 times 4 squared minus 4 times 4 minus what value? Okay, help me do some calculating here. What is 4 squared here? 16. Half of 16 is? So this is 8 minus 4 times 4. Four times 4? 16. Minus what? Okay, help me calculate. 8 minus 16 minus 2. Where's that going to get us? Negative 10, right? Good. So here's the deal. Listen to what I say, and listen to this carefully. When we input what value? 4. We got an output of negative 10. That means your vertex is the point 4, comma, negative 10. 4, comma, negative 10. Okay? That is your vertex. Now, I don't think I have 10 units on my graph. Do you guys have 10 units down on your graph? Okay. So, do you guys have a line of symmetry at 4 right now? So, then go down to 4, negative 10 for me. Okay? 4, negative 10, and plot your vertex. So, here comes our table, kids. I'm going to put 4, negative 10 right in the middle. Guys, what would be some good x values to choose now to try and graph this using symmetry? What's the x value here? 4. So to find some good inputs, maybe put in 3 and what else? 3 and 5. But what's going to be true about the values for outputs for 3 and 5 when I input those two? What's going to be true about my outputs there? Think symmetry. They're going to be the same. Exactly. Okay? All right, I need a volunteer to input 3 for me. Who's going to do that? Okay, let's do this mentally together. Let's see if we can't do this. What's 3 squared when I plug into our function? 3 squared, everybody. 9. How about half of 9? 4.5. Bank that, okay? What's 4 times the 3 here? 12. So I'll tell you 4.5 minus 12. Anybody got it yet? Negative 7.5. How about negative 7.5 minus 2 more, kiddos? Negative 9.5. So if we're talking about quadratics being symmetric, if I get an output of negative 9.5 when our input is 3, and you know the vertex is here, what's your output going to be when x is 5? Negative 9.5. You got it. Okay, let's input a 2 here. 2 is a little easier to work with. How about the 2 squared up there first when I plug it in? 4. Half of 4. Okay, so bank the 2. What's 4 times the 2 in the middle? 8. So this becomes 2 minus 8, which is negative 6 minus 2 more would be negative 8. Kids, if I input 2 to be an output of negative 8, what do you think inputting a 6 is also going to get you if we're talking about symmetry and as it relates to quadratics? You bet. Okay, so let's try and plot those points. You guys go ahead and plot those points. 2, negative 8, 3, negative 9.5, kind of guess where that's at. I would say if you have 5 good points, you've got a pretty good start to your quadratic. So go ahead and plot those points then. All right, 2, negative 8, you've already plotted the vertex for negative 10. Anybody ask you guys what you're doing yet? Not a 1? I think it's hot in here today.
Yes.
Yeah.
Humid. Holy cow. Do we have the air conditioning on here? You comfortable back here, Dave? Here? No? It'll be 100 degrees here or negative 100. That's a pretty good range, isn't it? All right, guys, real quickly, you tell me. I'm going to go back to my graph, which is right here. So I don't think I can get to negative 10. But which points were you plotting? What was after? How big? 1, 2, 3, 4, 5, 6, 7. You had 4, negative 10 down here somewhere, didn't you? Okay. What was your 3 point? 3 was negative 9.5. What was 2? Negative 8. So that would have been down here for me. So do you guys have most of your graph kind of down here in the third quadrant like that?
Yeah.
Okay. Now again, I'm a little skeptical saying this right here, but again, what's a good tool to use? I'm not telling you use this tool to get answers, but I'm saying let's use this tool maybe to confirm some answers. What was our function again? Y equals
0.5 x squared.
0.5. Did you say x squared?
Yeah.
I think I've got a problem with this. So y was equal to 0.5x squared. Okay.
Negative 4x.
Minus 4x.
Yeah.
And minus 2, was it?
Yeah.
I was just taking a look at this right here. Does that seem to maybe match what you guys have graphically right there? Where'd the vertex end up at down here, kids? Okay. Let's just check here. One point I was concerned about was 2, negative 8. Does that look about right? Is 2, negative 8 one of the values there? Okay. And then we also had 4, negative 8, or 6, negative 8, didn't we? Does that match right there? So you guys okay with this right here so far? Yes? No? Yes?
Yeah.
Okay. Again, I want to go back to this right here. I think it's important that, you're going to see a lot of stuff right here in standard form. All right? This stuff right here, I would put a star by this because this example, this is going to be something that gets hammered a lot. So this is really important right here. Okay? That's going to be something that you see a lot of as we move forward with quadratics. Okay? So understand the difference. What was the form in the top example up there, kids? vertex form. We were easily able to find a vertex, put it in here, and then just map some points left and right of the vertex to get a parabola. But here, if you're in standard form, what's the first thing you need to find?
Line of symmetry.
Find your line of symmetry. That's an x value. Once you found the line of symmetry, what are you going to do with that value? Plug it in, and get your vertex. And once you know your vertex, start building some points around the vertex, okay? All right, have you guys got what you need there? All right, let's move to the next page here. I don't know if we're going to get this done today, but we're sure going to try. So let's move forward here. Let's move forward on this. All right, so right here, kids, at the top of this right here, it says, ooh, finding a what?
Minimum or maximum value.
Okay, how about volunteer to read example 3 for me right there?
Find the minimum or maximum value of f of x equals 2x squared plus 8x minus 6.
Okay.
Describe,
I'm sorry.
you're fine.
Go
Describe
ahead.
the domain and range of the function and where the function is increasing and decreasing.
All right, no problem. Well, first of all, kids, what form is this in? Is this in vertex form or is this in standard form up here?
Oh, standard.
It is standard form, isn't it? All right. And the way I remember standard form is there's no parentheses. Okay. So if it's in standard form, maybe a good thing for us to do is identify our A, B, and C values. So A is something, B is going to be something, and C is going to be something. So what's that make your A value here, kids? 2. B would be 8. C would be, okay. Let's think forward first of all here. Notice your A value. Is that A value positive or negative, kiddos? Positive. So is this going to be a U shape or an arch? It's going to be a U shape, isn't it? Okay, so Sterling, if it's a U shape, is our vertex going to be a minimum value or a maximum value? Think U shape. The vertex is at the very top or very bottom of a U shape.
Minimum.
It's at the very bottom, isn't it? So it'll be a minimum, won't it? Okay. All right, so let's talk. We know we're going to have a minimum. I know we're going to have a U shape. So I'm just saying, you know what? We may not even need to sketch this over here. We know we're going to have a minimum because A is what kind of value?
Positive.
A is positive. All right. So let's find that minimum value. The minimum value is simply the vertex. So we need to find the vertex again, kids. So why don't you guys take a minute, use the opposite of B over 2A to find your line of symmetry. Plug your line of symmetry in and see what that gets you, okay? See if you can find your vertex first for me. Anybody ask you guys yet what we're doing?
Person, do we still find the x first? And
Yep. So you're going to do the opposite of B over 2A first. Yep, you're doing it just like you did in example 2.
Oh my gosh, Parson.
Yeah.
I'm getting so frustrated with Big Ideas Math.
Why?
Like, not even Big Ideas Math, it's the Chromebook.
Yeah.
I
Do you guys have new ones this year or not?
no.
What's the problem?
We get up next year.
Like,
What's the problem with the Chromebook?
whenever I shut it
Yeah.
to like pay attention, or like if they turn off the lights, I just shut my Chromebook.
Yeah.
And if I have Big Ideas Math open and like
Closes it and loses everything.
closes it and loses
Oh,
everything
shoot.
because the whole thing just shuts all the way down.
Really?
And I tried to change
You
the
know what? We had a
settings,
weird
it's locked.
situation though yesterday. That happened to Hunter Heitman. He did the whole thing. He shut it, and it said he had 0 out of 25 right. But I went in, and when I saw it in the computer, it said he had like 93% on it. So if that happens again, let me know, because I want to see if it's keeping a score for me when you shut it on my end. Okay? Because kind of the same thing that you're talking about, he described yesterday, and I was still able to pull his score. So let me know if that happens again, okay?
Yeah, it's like deleted it like 3 times.
All right, we'll see if we can't fix that. All right, anybody have a line of symmetry value for me first? Negative 2. Yep, that's found by saying, okay, my x value for line of symmetry is at opposite of b over 2a. What is the opposite of b, kiddos? Negative 8 over 2 times 2. And this becomes negative 8 over 4, which is negative 2. So the line of symmetry is at negative 2. Now what do I need to do with negative 2, kids? Plug it in. So here we go. We're going to plug negative 2 in. So we're going to plug in negative 2 into our function. So it'll become 2 times negative 2 squared plus 8 times negative 2 minus 6. All right, kids, help me. 4 times 2 right here is? Wouldn't this be 4 right here when I square that? And then times 2, the first part would be 8, wouldn't it? Let's see, a positive 8 and a negative 2 would be minus 16, and then minus 6 more. Anybody know what that equals? Close. Negative 14. Okay. Okay, so what happens here, kids, is this. We're not even going to use the graph, but I'm going to show you what happens. You know the vertex is going to be where, kids? What comma what? Negative 2 comma negative 14. Now I'm just going to make a small sketch of this. Okay, I'm going to make a small sketch of this, and then I think that when we get this done, we'll call it good for a little bit. Negative 2 comma negative 14. So which quadrant would negative 2 comma negative 14 lie in? First, second, third, or fourth?
Third.
Okay, so bottom left. Left 2, down 14, right? Hey, quick question, kids. You told me that then when this vertex was here, the a value was positive. So is this going to be a U shape or an arch? Going to be a U-shaped parabola that comes through that vertex like so. Okay? So the first thing that asks us to do is say, hey, where's your vertex at? Okay? We know how to find the vertex in standard form. I think we're going to be okay with that. What other questions did they ask about this step? They wanted to know where the graph was increasing and decreasing. Okay. You always look at increasing and decreasing stuff as you move from left to right. Okay? So if I start here and start moving right, if I start in the far left, start moving right, is my graph increasing or decreasing to the vertex?
Decreasing.
Okay, so it's decreasing for all x values that are, and again, this is where your line of symmetry becomes very important. If I have a line of symmetry right here at negative 2, like so, kids, look at the left half of the graph and say, oh, as I move left to right, the graph is moving down. So what I say here, guys, and you'll want to write this in your notes, the graph is decreasing and increasing at the same time. Okay? What's the x value for the vertex down here, kids? Okay. So left of negative 2, this graph is decreasing. So we say it's decreasing for x values that are less than negative 2. But guys, once I get to the right of negative 2 right here, what starts happening to my graph if I keep moving right? As I move right of negative 2, am I increasing or decreasing? Increasing. So it's increasing to the right or for values greater than what? Yeah, my graph now would be increasing for values x greater than negative 2. All right? So they say, where are you increasing? Where are you decreasing? Guys, there's a lot going on here. Very important section, okay?
Can you put it back on?
Sure. I'm guessing here?
Yeah.
Okay, I think that's a lot of information in a day, and I didn't get all the way through the stuff I wanted to get through. So how about we just kind of soak up what we had today. We'll pick this up tomorrow and then move forward with it tomorrow. So consequently, No homework today. Fair deal? Fair deal?
Yeah.
Okay. All right, I'm going to stop that. Did you get what you needed there?